How to access the Emergency Response Data Platform. Any public safety agency can access life-saving emergency data through the RapidSOS Emergency Response Data Platform. There are two ways of doing so. RapidSOS Portal is a powerful web-based tool that enables you to manage emergencies and access location and supplemental data for every call in your jurisdiction. Signing up for RapidSOS Portal is easy and only takes a few minutes. In addition to emergency management tools and data, RapidSOS Portal includes a training platform as well as administrative tools to manage user permissions, track usage, and analyze trends in your agency. To learn more and sign up for RapidSOS Portal, please visit rapidsosportal.com. RapidSOS also integrates with every major CAD, CPE, mapping, or other public safety softwares. With an integration, you can receive RapidSOS data through your existing workflow, and you won't need any additional screens, tabs, or windows. To learn more about integrations, visit rapidsos.com/public-safety-partners.
We will go ahead and officially get started. Welcome to the 2024 summer fall EMP study group for On Scene First. This is week 13, Next Generation 911 Part 2. Last week we went a little bit into it, and then I had to cut it short just because this is where the bulk is, the meat and potatoes, and I didn't want to rush through that with only like 10, 15 minutes or so left in the session. So we'll jump back into that today. If you are stumbling upon this video on YouTube, and it is after, I would say today, June 19th, even though we were officially ending on June 21st, this will be the last live session. And if you would like access to all of the previous recorded materials from this last session, go ahead and head over to onscene1st.com/training/study ENP and fill out the form there, and you will be added to the Google group, where you are able to access all of the recordings, the PDFs, as well as the MP3s and any practice exams and any other materials that I have sent. All right. My computer's acting wonky. Usually I'm on a much bigger screen, so I apologize. If you do want to be notified of any of the fun, cool things that I do on a regular basis, head on over to the website onscenefirst.com and go ahead and register there for our newsletter. There'll be one that's going out in the very near future. So if you want to head on over there as well. I want to say thank you to RapidSOS, my premier study group sponsor. They have been with me since the beginning of the first session as we close out the last live session for now, and it is number 8. So lots of ENPs have come through the live sessions. Doesn't mean that I'm not going to have the materials available and update them accordingly. I'm just realizing that having a consistent day for a period of time is proving to be a bigger challenge. And so I will continue with the study group. It's just going to be kind of behind the scenes. So if you stumble upon that in your after this last study group, just so you know, that's what we're planning at the moment. So as we get ready to jump into the Next Generation 911 stuff, I just want to throw a few terms out there because some of the terms have, some of the abbreviations, some of the terminology uses these particular words. So while I know in general, folks probably know what these words are, I think when we test, sometimes we forget to just break down the words or break down the acronym to be able to kind of think logically about what this particular thing is doing. And so if you focus on that or recall that root word there in the title, um so you'll see what I'm talking about, and I'll point it out then. You may be able to thoughtfully think back on what is the process, right? So, first, policy refers to a set of rules or guidelines that govern how and when a network operates and how users and devices can interact with the next generation 911 network. So, it's just that rules and guidelines, right? So if this, then that, um, this is how we would proceed forward. Policies can cover various aspects such as security, access codes, control, quality of service, the QoS that we talked about last week, data management, and compliance. And then the protocol refers to a set of standardized rules and conventions for data communication between the network devices. Protocols define how data is transmitted, received, and interpreted by the device within the network. So the policy is kind of if this then that we're going to do this. So if the call is a legacy 911 call going into a next gen 911, then it's going to follow this particular path. So if this then that, and then the protocol is how are we going to do it? We're going to do it by using this piece of technology, etc. And it's going to take this route or it'll go here. A proxy refers to a server that acts as an intermediary between a client and a destination server. Proxies are used to improve security, performance, manageability of the network traffic by caching content, filtering requests, and masking the client's IP address. In other words, very simply, just like a healthcare proxy, it's going to act on behalf of something else. So you'll see that as we go through some of these terms. Uh-oh, I hope, okay, I just wanted to make sure. I had to download a PDF to recreate the presentation, and it looks like the format is off there, and I will fix that. So I want to talk about the term functional elements. I do recall seeing that on my exam. I don't remember necessarily what it may have been looking for, but it is important to understand that functional elements are the pieces of the next generation 911 network, like specific pieces along that route. So refers to a specific component or module in the next gen 911 architecture that performs a particular function or task. These functional elements work together to enable implementation and operation of the next generation 911 system, which aim to enhance emergency communication and response capabilities. So when you look in your body of knowledge, the outline from Nina, and in the manual, when you look under functional elements, it's going to list a handful of these components or modules that are part of the next generation 911 system. So the first one we are going to talk about, and I just want to clarify this. So while I tried to put these in a logical order of things that we're going to learn about, like where it is in the next generation 911 system, just know that every system is different. And some systems are fully, I3 compliant with all of the pieces. Some are part legacy and part next gen and then back to legacy. And so it really is challenging to identify where each component is on every system. So as you're thinking of the next generation 911 rollout or how we will follow it through the network, just understand that there are pieces that are etched in stone and then there are pieces that are not. So I'll let you know what I mean when I get there. Okay. So just know that I tried to put them in a logical sequence of orders and how we're going to kind of display them out in some images and diagrams that I created. But it's not etched in stone for every agency. And the reason why I say that is because when I've gone through it in the past, some folks have reached out and said, well, you don't always have this, or this isn't always there. And I was aware of that, but it is important to say, if you're one of the folks in your agency that's been rolling out next generation 911 stuff and you're like, no, that's not where that goes, just know that in another agency, it may go there. So hopefully that makes sense. So the first one we're going to talk about is the emergency services routing proxy. It serves as an intermediary, as we mentioned in the definition, in the emergency call flow, helping to assure that calls are routed efficiently and accurately to the appropriate public safety answering point, the appropriate PSAP. The other thing I want to mention here too is you will see that a lot of these terms, they sound familiar, or they sound similar, not familiar, they sound similar to each other. But again, it's going to break it down. You want to take the root words and break it down, right? So emergency services, yeah, we know that. Routing proxy. So it's going to route on behalf of something else. It is an I3 functional element that is a SIP, session initiated proxy server, that selects the next hop. So I want to go back to SIP, meaning the way that it establishes a hello, how are you? I would like to get on your network. And then there's a conversation that takes place. And then that connection is set up. And then it's delivered to the final destination and then all put back together. So that being the session initiated protocol. It's the hello, the message in between, and then the offload, disconnect, or closing out that communication system connection that selects the next hop. Routing within the ESI net based on location and the policy. And now, where does the policy come from? It utilizes the PRF. So in this position, in this picture, you see the ESRP is checking boxes. So basically, it's going to check location. It's going to make sure that the policy is being followed. It's going to check off the boxes in the policy using the policy routing function. We'll talk about that in a little bit. We will also talk about what the hop is, but I'll mention it here as well. So as an I3 functional element, that is a SIP proxy server that selects the next hop, it basically selects the hop is which direction is it going to go and how is it going to get there. So the hop, when you see the word hop in this case, you may have a few different routes to take. The route that it's going to take is considered the hop. So I'll go back to default and alternate routing here for a second, just to make this clear. If I have an alternate, if I have a 911 call that is heading to, and I'll use my agency because it just makes it easy. If it was heading to the Rochester 911 center when I had my center, so the 911 call jumps onto the NextGen network and it determines based on location and policy that it is going to the Rochester 911 center. It is going to get on the piece of the network that is going to send that call to the Rochester 911 center, and that's considered selecting the hop. Which way is it going to hop on over to the 911 center? If there's something in the system that identifies that that call cannot get to the Rochester 911 center, then it's going to need to select a different hop. And it selects whoever we have identified as our alternate, which is going to be the next agency over, the Marion Police Department at the time. And so instead of picking the hop that's going to go to the Rochester 911 center, it's gonna select the hop that goes to the Marion Police Department. And then once that call gets delivered, everything's great. Now we take the 911 call that doesn't know where to go, because of various reasons, whether it's a non-provisioned phone, they're using a femtocell, it's a multi-line telephone system, any of the cast of characters that cause our calls to say go to Northern 911 in Canada, then the ESRP is going to select a different hop. It's going to say, I don't know where to go, but I have to go somewhere. So it's using the policy routing function. Policy says if this, then that. And the if this is if you don't know where the call has to go, then it needs to go to this hop. So the ESRP is the one that's kind of checking the boxes saying, all right, maybe we have two locations because it's a Wi-Fi dialed on a T-Mobile phone that we're getting one location from the tower, we're getting another location from the device in the Wi-Fi dialing, and I really don't know where the call needs to go. So we're going to go ahead and send that to Canada. We've talked about this before. And so it's going to select that hop to head it over to Canada. So hopefully that makes sense. There is an ESRP at the edge of the ESI net. There's usually one at the entrance to the next generation 911 PSAP as well, to make sure that, like I said, if it jumps onto the network and it's trucking down that network to get to the Rochester Communication Center, but it can't get there, maybe all our lines are busy, or we have an issue and we've had to send our call somewhere else, then the ESRP is going to go, oh, nobody's home, we have to go somewhere else. So it's going to select the next hop and it's going to send it to our alternate. And just that last piece of information is there may be one or more intermediate ESRPs between them. So that's where I was saying, like, not every 911 center has all the same components and all the same places as far as the next generation 911 system goes. The next is the location information server. It is a functional element in an IP capable originating network that provides location of endpoints. It can provide location information to any IP device within its service access network. So I'll just give you this example here. The RapidSOS portal, the emergency data platform from RapidSOS, was one of the first that was dipping into a location information server. RapidSOS had to stand up a location information server and additional data repository to be able to have the device-based location to be able to send that into the 911 centers. So location information server is where that location is going to be pulled in the next generation 911 network. So here is just the beginning phases of seeing how the call is going to maneuver with a couple of the pieces in place, and we're going to uncover them as we go forward. So call is placed. The device knows its location. When that 911 call gets placed, it is going to hit, one of the first functional elements. Now, mind you, not all the pieces of the call routing are in these little displays. Just want to make sure that that is understood. These little diagrams that I'm showing you is to identify where you will find that particular functional element as we move through the next generation 911 system. So the location of the phone is determined based on the emergency service routing proxy, the ESRP. It is checking it's going to use the policy from the policy routing function to determine which 911 center that call needs to go to. And so what it's going to first do is it's going to check the location information server, and then it's going to come back. So you can see this. So the phone knows its location. That location is being sent to a location information server. Once it hits the ESRP, Emergency Service Routing Proxy, it is going to query the LIS, the location information server, and the ESRP is now, it has that location. And now it's going to say, based on this location and these policies, we are going to send it to this 911 center. And then there's a few other things that are going to come into play. So that's why they're all start off. We're gonna go find those as well. The the location to service translation, LOST. If you notice that the abbreviation, the L, capital L, lowercase o, stands for location. So location to service translation. The LOST protocol, this is a protocol, so it's if this, then that, is a key component of the next gen 911 systems. It provides essential functionality for emergency services by translating a given location into a corresponding public safety answering point and routing emergency calls to the appropriate authority. So it's basically the protocol, it's the protocol that sits behind the scenes. It's the protocol that the ESRP is grabbing from the PRF, the policy routing function, and it is the I'm trying to think of the best word to use, but it's a protocol. It's the LOST protocol. Okay. So if the 911 call is lost, right? It doesn't know where to go yet. It's gonna get that location. The ESRP is going to use the policy and it's going to send it, but the LOST protocol. Okay. And so here we are. So the location determination, again, we jump onto the ESRP. It's going to use the policy routing function. It's going to check the location information server, and then it's going to go back to the ESRP. And now using the LOST protocol, it's going to make a query against the LOST protocol and determine, this is where we determine where that call is going to go. So it is the LOST protocol that is being used to turn that location into something that is usable. Okay. So now it's coming back to the ESRP, and this is all happening very quickly and simultaneously. And I know I'm talking through it slow because I just want to be able to, I want to make sure that I'm saying everything that I need to be saying. As the call gets placed, goes to the ESRP, checks it against the location in the location information server, comes back to the ESRP, has the location now in a form that it can be sent as a protocol query to say, hey, this is the location. What is the protocol? Where are we sending this particular call? Okay. And then the next step is the emergency call routing function. Okay, emergency call routing function. When you look back, I want to go back here for a second. So emergency service routing proxy is making the decision, right? Because the proxy is making the decision. So if I'm a healthcare proxy, I'm making the decision because my dad can't make the decision, so I'm his healthcare proxy. So the proxy, the ECRF, is checking boxes, checking policies, and making decisions based on the information that it has. Jump back ahead to the emergency call routing function. And again, looking at the words as you're doing the exam is going to be helpful in having you break down what is the best choice in the answer. So if I'm looking at the answers and I have one that is a policy, I have one that is a proxy, and I have one that is a function, well, the emergency call routing function is going to be the functional element, right? So it's an I3 functional element that is a lost protocol. And again, the lost protocol is just the name of the mechanism that is moving this through our network. It is responsible for determining the appropriate public safety answering point to which an emergency call should be routed based on the caller's location. And while it sounds very similar to the emergency service routing proxy, ESRP. Sorry, I'm talking slow because I want to make sure that I'm saying them correctly. While they both have a role in sending the location and determining which PSAP, it is one's the proxy making the decisions and the other is the doing, sending it where it needs to go. So the ECRF uses geographic information and predefined service areas to make routing decisions. When the emergency call is made, the ECRF processes the caller's location, determines the appropriate PSAP based on that information. Geospatial routing replaces MSAG-based routing, and it replaces, and I just noticed that typo, so it replaces the selective router. So the ECRF is, in theory, the selective router, if you will, but it's going to be based on the location of the device that has been sent to it from the ESRP, that it has come from the location information server that has come specifically from the device. So let's see what that looks like. So we'll go back to the location determination on the device. It is sent to the ESRP, which now the ESRP has to obtain that location using the location information server. Once it has the location, it's going to go ahead and send it to the lost query. It's going to make a lost query, and it's going to return that location back to the ESRP. The ESRP is going to send it to the emergency call routing function. And just like the old selective router, it is going to determine this is where it is going. And it's going to start the process of getting that call sent on. In addition, the emergency call routing function is going to, at this time, it is determining what the URN is. And if you remember, it was uniform resource number or name, sorry. And in many cases, it is service SOS. And you don't need to know that. Um, but this is that identifiable number that is going to follow this record through its entire journey in the network. So an example scenario, caller, and there's a few of there's some of these for each one. So caller, a person dials 911 after witnessing a fire. The call is received by the ESRP within the NG911 system. There's a location query that is made. So the ESRP, the little check boxes, queries the location information server and determines the caller's location. So it's going to get the latitude and longitude. The ESRP sends a loss query to the ECRF to find the PSAP that is responsible for the given location. Okay. The routing decision, the ECRF, the emergency call routing function, responds with the URI, the Uniform Resource Identifier of the appropriate PSAP. The call routing now happens. The ESRP routes the call to the identified PSAP where it is answered by an operator who can dispatch the emergency services. So there's your kind of call scenario. The policy routing function, which we had talked about, and it's at the bottom of the ECRF, the policy routing function applies predefined policies to determine the best route for an emergency call based on various criteria. It determines the next hop in the SIP signaling path using a policy. There are two types of the policy routing function: the call management rules and the routing policy rules. So the call management rules modify call flow within the NextGen 911 system before the PSAP call delivery. And so the policy routing function, before it gets to the 911 sensor, before it gets to the 911 PSAP, the policy routing function is in place to determine which hop, which signal, etc. It is the policy routing function that is the rules, and it is the ESRP that is implementing those rules. And I know it's confusing, and I'm trying to do my best to explain it. The routing policy rules modify normal call routing for time, date, PSAP availability, and similar conditions. So that means like call management rules this is how the call is going to be managed. Routing policy rules are going to be the next step, and that isn't always the same, right? So the call management rules is going to be the same because it's going to say, based on this criteria, this 911 call, this is generally how it's going to go. But the routing isn't always going to be the same. If we run into an issue, if there's a problem with the route that it's supposed to take, it has to seek an alternate route. So the routing policy is subjected to change because of various factors, right? So there's that. The hop networking, which I referred to, is a portion of a signal's journey from the source to the receiver. It is the step from one network segment to the next. It's typically to the PSAP, but it could be elsewhere. So when you are, I tend to look at these little icons here as a piece of the routing mechanism, and the hop is taking it from one place to the next. I don't know why it's called a hop. I don't know if there's an acronym for it, but it is called a hop, and I just referred to it or I think of it as it's hopping from one place to another on the network. And the policy routing function is going to play a role in that, as is each other functional element. Yeah, some of my formatting is off. Then there is the location validation function, LVF. The location verification function is a functional element of the next gen core services that is a lost protocol server where civic addresses are validated against authoritative GIS data. Okay, so when we get that location from the location information server, the LVF, location V validation function, is going to validate, just like we would MSAG validate, the address for making sure that it's appropriate. So the LVF is replacing that MSAG validation process for next gen purposes. So a civic address is considered valid if it can be located within the database uniquely and is suitable to provide an accurate route for the emergency call. So the location validation function is going to take that location that's been provided. It's going to check and make sure, does it fall into this geographic GIS boundary? And if it does, then we're going to go ahead and let it continue on its merry way. And so that looks like a duplicate. Sorry about that. And then the policy store. The policy store, and you may see it in your manual, or I think it might be on the body of knowledge. It is a functional element in the ESINet that stores the policy, the documents, and the rules. So while you can envision it to be like an actual store where I have to go in and, and purchase policies and procedures, I'm going to use it, a filing cabinet, as a storage place, because not everything is consistent, not everything is the same, and not everything is, as it should be in 911. But there is also a definition of PRR that has appeared in a few places, and it is the policy routing rules. These are predefined guidelines that determine how emergency calls should be routed to the appropriate public safety answering point or other emergency services. These rules help ensure that emergency calls are managed efficiently, considering various factors to optimize response times and resource allocation. So again, breaking each piece apart, is I have the policy routing function and the policy routing rules. So the policy routing rules will live in the policy store, and then when they are needed, they will be obtained from the emergency service routing proxy, and the policy routing function will be engaged. Sounds simple, right? Maybe, maybe not. Additional data repository. The additional data repository collects, stores, and makes accessible various types of additional data that can be retrieved by PSAPs and emergency responders during the emergency call. The ADR dereferences a URI, Uniform Resource Identifier, website, basically, right? Or the identifier that identifies the website, that is passed in a SIP call info header field, or we pronounce it PIDFlow element, and returns an additional data object block. So this, an ADR, is, and I'm going to tell you what PIDFlow is in just a minute, but RapidSOS, as I said, stood up an additional data repository. So any of the additional data that is coming from the device, whether it's the Apple Health information, SiriusXM information, health emergency profile data through the American Heart Association, additional information from the device, it is living in the additional data repository. And there's a couple of times throughout the call where there will be a query against the additional data repository. The identifiable searchable additional data repository is just a searchable version of the ADR. So you have the ADR where the information is living, and then you can be able to search that ADR. So think about the Rapid SOS portal when it first started out, and you had to type in the phone number. That would do a identifiable searchable. It would have been considered an identifiable searchable additional data repository. And here is where the additional data repository piece lives. So there are a few places where an additional data repository can be queried. So it can be queried. So when we look at the ESRP, it's going to check with the location information server. And again, I broke it down into pieces. So once and you're going to see it all put together at the end. So the ESRP is going to request the location from the location information server. But before it returns it back, it needs to validate that location. So it's going to utilize the location validation function, which simultaneously is checking the additional data repository. And then it all comes back here once it's all been checked and validated using the lost protocol query. It will send the call to the emergency call routing function, which then requests the URN. Again, over here, we can check the ADR, and then it gets to the 911 center. And then depending on, you may have something that additionally checks the ADR there. And again, I've just put these things here to show you there are different places where different things can be queried throughout the process. You are not going to be quizzed on where exactly in the process is it. They can't, because it's not something that's consistent. So don't necessarily get hung up on where the things are happening. Consistently understand that the ADR can be in multiple places. The LIS is going to happen at the beginning of the call. The LVF is going to validate, because the ADR could also be being queried. So I could move this ADR down here and it could be queried at the same time. And then everything goes through the location validation function. So just know that I'm just putting them there for visuals. It's not consistent. It's not etched in stone as far as these are going. The HTTP enabled location delivery. It is called HELD. And when I first started at Rapid SOS, I remember Reinhard saying, like, over and over, and he was like, the technology is using HELD via Pitaflow and all this. And I was like, I don't even know what he's talking about. And for a long time, I still didn't know what he was talking about, but I now know what we're talking about. So HTTP, as you learned last week, is part of that URL, right? So it's an internet-based protocol. And it's a protocol. This is a protocol used in next-gen 911 systems to acquire location information, LI, from the list. So all of this stuff is going through the network with the URLs, the URNs, the URIs, etc. And they're being used in different places. So that's how you have to envision it. So when you look at something like the Rapid SOS portal, and it's all being data driven versus network driven in that aspect. When I say data driven, I'm thinking more IP, right? Or the ESI net. And that is why when we have situations like we did in Massachusetts yesterday, when the 911 system went down, if you had access, or anytime a 911 system goes down and calls are not able to be delivered to 911, over the top solutions, such as the Rapid SOS portal, still have the ability to show that somebody on their device is trying to call 911, because it's all going through an IP network. It's not going through a like a technological network as the system does, right? So they're two separate entities, but it's using HELD, it's using the HTTP enabled location delivery. It's using a URL to go get that location, to bring back the location, to validate the location, to send the location to the LIS, information to the ADR, the additional data repository. It's all through HELD. It enables the delivery of the location information related emergency calls over the HTTP. It's usually with the S, which we learned S is for secure. Hypertext transfer protocol HELD allows devices or applications to request and receive accurate and up-to-date location information, aiding in emergency responders and locating the individuals during the emergencies. It identifies how devices can request and receive their own location information over the internet using the HTTP and HTTPS. HELD is only for 911 addresses retrieval. Therefore, HELD is held to a higher standard. So when you think of HELD, and if you can think of that HTTP enabled, the H of the HTTP being held to a higher standard, it's the URL that's attached that's sending it through the IP network. Okay, so here we are again, and we have just added this image here. All of this stuff is going through the network using the HELD protocol. PIDFlow, presence information data format, location object. That is what PIDFlow stands for. And again, the capital L with the lowercase o stands for location. Well, sorry, in this case, it's location object. I apologize. Forget that on this one. Presence information data format, location object. It provides a flexible and versatile means to represent location information in a SIP header using an XML schema. We talked about this last week. And that's the information that had just gone out. It may contain geodatic or civic location information. It's provided by a device or a service provider via the location information server. And think of it as next-gen ALI minus some of the things like subscriber or carrier information. It is the data. PIDFlow is presence information. It is presenting the information on the location into the 911 center. So presence, presenting, that's how I would think of it, it is how that data is going to be presented into the 911 center. And with PIDFlow, I created this little image over here, is that it's using that XML schema, which is just a bunch of code and all that stuff. How it is presented at the PSAP is based on the call handling equipment that you have, but it's the presence information data format. It's how it gets there. So it gets there using the XML schema, which is all of this code, but it's not how it's presented. It's how it gets there, how it looks when it gets there, but how it's presented is based on the equipment that you have in there. So this is just a closer image of what PIDFlow could look like. So when these are two components that are very much a part of the 911, next-gen 911 is using the HELD protocol, the HTTP, and it's held to a higher standard. It's using that type of HTTPS protocol to maneuver it through the system. And then the PIDA flow is how it is being presented, how it's being presented at the 911 center, but how it is displayed, two different things. Border control function plays a crucial role in managing and ensuring interoperability and security of emergency calls across different jurisdictions, networks, and administrative boundaries. It provides a secure entry into the ESI net emergency calls, provides a secure entry into the ESI net for emergency calls presented to the network. The border control function incorporates a session border controller and the firewall between the ESI net and external networks or other elements of service. So just think of it this way, right? So the border control function can appear all over the NextGen 911 network. So I don't think you'd see a question on where would you find it, because there are some that go from the device to just getting onto the ESI net, and some that go from the location server here in the query and between the the ECRF and the PSAP. And so there's no specific place that it's going to ask you, like, where will you find it? It's probably more or less like, where could you find it? Spatial interface is a standardized interface between a GIS and functional element that consumes GIS data, such as the ECRF, the location emergency call routing function, the LVF, location validation function, mapping data services, and geocoding services. It is a data transport interface. It is not a functional element. So when we talk about an interface, it's, two things working together to create one thing moving forward. The Forest Guide. Okay, I was like, where did they go? All right, so the Forest Guide is the first component. Is the goal of the Forest Guide is to have location-based routing no matter where you are in the world. We're not there yet. We're not internationally there yet. But that's the goal of it, to have location-based routing no matter where you go for your emergency calls. It is a place of resolution for 911 calls to get to the appropriate local 911 center if the call should be out of area. So basically, this is like if I'm in Rochester, Massachusetts, and I get a call from someone in my jurisdiction and they say, I need an ambulance for my mom in California. In theory, I should be able to use the Forest Guide tree to get that call down the ESI network through different entities to California. And with it goes the Annie in the Alley. Now we're not doing that these days. But that's kind of the guide of that's one of the premises of the Forest Guide, is to get the call. It's a place of resolution to get the call from one place to another very far place. See, in Massachusetts, I can send a 911 call no problem to a place that's 2 hours away from me in Massachusetts, because they're part of our network. They're all on our network. They're built into our systems, etc. But as soon as you step over that state line into a different system, the goal of the Forest Guide is to be able to utilize all of the next generation 911 services to be able to get that call to where it needs to go. It is also a lost protocol. All it does is help an ECRF contact the correct ECRF outside of its area by redirecting lost queries. So if it came to me and I need to send it somewhere else, I'm going to use the lost protocol, and the ECRF is going to redirect it to a different ECRF, which may inadvertently send it to another ECRF as it travels across the country. It is the hope of the folks that are standing it up that there will be at least one in every state and that it will be stood up internationally. This video right here, so when you get the PDF, you can click here or you can just Google NIOC Forest Guide Technical and Functional Overview. It covers, it's a really good video, and it covers the Forest Guide, the Loss Protocol, and PITAFlow. And I think, if I'm not mistaken, it's Brandon Abley that is narrating. But basically, it was his words that in the beginning says, if you are lost in the forest, use the Forest Guide. And so I put, it was in the NIOC video, but I do think it's Brandon Abley who is narrating. But this was a very helpful tool to help better understand what the Forest Guide is. NG911 transitional elements, location database, LDB is a server that retains today's alley's current information, functionality, and interfaces, and can utilize new protocols requirements in a next-gen 911 deployment. So it's putting kind of two pieces of the system together. You do want to know which is what when it comes to the gateways. There's a few gateways that are going to be in the system, and the image, the diagram that I'm going to show you in a little bit is going to kind of put them in the places where they need to go. But again, just think logically about it, right? So legacy network gateway. So what that's telling me is, like, it's legacy, it's old, and it's the old network, and the gateway is going to put it on the new network. So it's that gateway that sits between the old network and the new network. So it provides an interface between a non-upgraded legacy originating network and a next-gen core services enabled network. So legacy network, you got this old funky network over here. The legacy network gateway sits between the old network and the new network, and it allows that information to be moved over there. The legacy PSAP gateway provides an interconnection point between an ESI net and a legacy PSAP used in call delivery transfers and alternate routing when legacy PSAPs need to interact with an ESI net. Now, remember, when we are putting these things in place, not everything gets done at one time. So we're building out the ESI net. We're building out the I3 capable PSAPs. So there are times where there has to be pieces where, oh, look, it's an ESI net. We've stood up the ESI net, but we still have a legacy PSAP. So what has to happen is there has to be a legacy PSAP gateway that's sitting right outside that PSAP that changes it into a format in which the legacy PSAP can obtain that information. And then the legacy selective router gateway is just that. It provides an interface between the 911 selective router and the ESI net, enabling calls to be routed and or transferred between legacy and next-gen networks. And again, I may have a piece of the system that's set up over here. And when that call hits a certain place in the network and it needs to be transferred to a agency that is a legacy agency, and pieces of the network have not been upgraded to next generation, then we need that legacy selective router gateway. NGSEC, that stands for Next Generation 911 Security. It defines a holistic security standard for Next Gen 911. The reference name for that document is there. And then when it comes to the 911 call routing, I'm just going to kind of show you just a couple of things to help you have a better visual on how the 911 call gets routed. So landline legacy 911 routing. And I apologize because normally I have this animated and I'm able to speak to them as they appear. So 911 call comes in, call goes to the central office. The central office is where it will pick up the Annie, the phone number. That phone number is then sent to the selective router. The selective router is going to determine where, based on where the call is coming from, which 911 call it is going to be, which 911 center it's going to be sent to. So it's going to send that phone number and the call over to whatever PSAP it belongs to. So it's picking this PSAP versus this one. And then once that phone number hits the 911 center, the phone number then gets parsed out. The phone number gets sent to the ALI database. Once it is sent to the ALI database is going to match up the phone number with the location in the ALI database, and then it's going to make a validation, if you will. It will MSAG validate it against the MSAG, which is the Master Street Address Guide. And then once it validates it, then the ALI database is going to send the phone number and the address back to the PSAP to which it belongs. So if you recall me saying numerous times before, is that not everything comes to the 911 center at the same time. The phone number comes in first, the phone number gets sent out for a query. That query will then be validated against the MSAG, and that ALI information is brought back into the 911 center. When we look at a 911 call from a wireless device, we're going to have a couple of different pieces. And these are things that we talked about in other places, but this is the visual that you can utilize to see where it goes. So 911 call gets placed. It is the call hits a 911 tower. The 911 tower decides which mobile switching center it is going to hit. The mobile switching center identifies the cell sector, and this is where the PANI or the ESRK, which we've talked about before, the emergency service routing key, which is similar. So in the new system, in the new, not necessarily in the new system, but in the wireless devices, and additionally in the network, the PANI and the ESRK is, and the cell sector is picked up at the mobile switching center. The mobile switching center sends the PANI and the voice to the selective router, which is also called the E911 tandem, right? Tandem being two, and we kind of connect two together. The selective router is then going to rely on the selective router database. So the voice and the PANI is sent to the correct PSAP at the direction of the selective router database. And so the selective, a wireless call needs to have a query made against that selective router database because it could be coming, that information could be coming from anywhere. So now the selective router database says this is where it goes, sends it to the PSAP, phone number is parsed out, the phone number is sent to the ALI database, and then it is queried. And again, there will be an MSAG validation, but that is more for not necessarily the street address, but the street in general, that it belongs in this jurisdiction. So that range, as we talked about before. And then our next gen 911 routing. So this is where it gets a little wonky. And like I said, just know that your system may be a little bit different, but I tried to make this as clean as possible and as easy to understand the components of each place. So the 911 call gets placed. Before that call can get onto the ESI net, it is probably going to be met with a border control function. It is going to travel down the ESI net where it is going to meet the ESRP, the Emergency Service Routing Proxy. So based on information that it is going to obtain from a few different things, it's going to use the policy routing function to determine the next hop, meaning the next road, the next IP road that the call is going to choose. Now, mind you, this is just one image, one route. There could be an ECRF over here. There could be one over here. And that hop is going to determine, so the ECRF, based on this information over here, which I'm going to go through in a second, is going to determine which hop it's going to go to. So the ESRP cannot make the decision on which hop it's going to hop onto and head on over to the PSAP until it has done some things over here. It's going to send, or it's going to request the information based on the call information to the location information server. At the same time, the SI is in play, as well as an additional data repository maybe being queried, and the held protocol is being used in this case. And then when this information is all ultimately delivered, it is going to be delivered in the PIDFlow format, which is an XML schema, if you will. And so once we have that location information, it is going to go through the location validation function, LVF, come back to the ESRP. The ESRP is going to take all their information and go, okay, all right, let's see. We have this location and it's this address, and it based on these rules, we're going to go ahead and send it to this 911 center. And it could end up at 2 different types of 911 centers. So now that we have the ESRP has done all of the checks and balances, it's going to send it to the ECRF to actually be sent, right? So the function, the proxy is acting on behalf of using policies from the policy routing function, and it's going to go over to the ECRF, the emergency call routing function. And then that function is going to, and again, you see the border control functions in different places. So it's going to send it down the ESI net. Now we're going to get to which one is it going to. If the call is going to a NextGen 911 i3 PSAP, we're probably not going to have too many more steps. We will have all that information that is being delivered to the center with a pit stop through a BCF before it goes into the center to protect their equipment. But if it's going to a legacy center, it needs to, at that fork in the road, you see that it has jumped onto the legacy network, which I apologize. I should have, I don't know why that went back. There should be a legacy network gateway here, and I will add that to the image as well. So because we need to change it from the new network to the older network. I don't know where the gateway went there. There should be a gateway there. Oh, actually, it might be on another page. But for this information to get into the PSAP appropriately, you see that there is a legacy PSAP gateway here. That legacy PSAP gateway is going to sit right before the PSAP, and it's going to allow that information to be let in there. The phone number is going to get there just as it would, sends out to the ALI database, validates against the MSAG, and then brings back the ALI. Now, there should, in theory, should be 2. So if we have 2 systems that play here, and that call is starting on one network and then ending on a more advanced network, you will still have pieces of the component as they are today. So 911 call gets placed, goes to the central office, goes to the selective router, queries the selective router database, validates against the MSAG, comes back to the selective router, and now it's going to send it on its way. If it's going on to an ESI net from a legacy system, this is where there is going to be a legacy network gateway. So there could be one here where this older system in the initial part of the call is getting onto the ESI net, and there could be a legacy network gateway over here when we go from the ESI net back onto a legacy network gateway. So there's that. I highly recommend heading over to YouTube. Click on the links that you see there, or just put in a search for Commercial Electronic Corp. And these two videos right here, Beth English does a great job in explaining some of the stuff that I had explained to you today. I get some of my knowledge from her. She's very well versed in this too. There's a little more added information, but still it's any information that you can get is much better. So I hope this makes sense. I know it's confusing. I know there's a lot. I have done my best. I feel like I screwed something up. I feel it in the back of my bones, and I have a feeling I know where it was, so I'm going to look into that, and then I will change it for you and let you know if I did make the mistake that I think I did. So with that, I'm going to, I guess we're done. I guess I didn't add my little thing at the end with my email address and all that, but with that, if you have any questions, don't hesitate to reach out. We are getting close to the summer testing period, and I promise you'll have all the information. I am working very diligently to get it all to you. So until next time, heroes, stay safe, stay strong, stay here. We need you.